Here you can see everything in a video once more. We have the bioreactor and you can see it also standing outside. The algae is growing inside the bioreactor. We give the cells CO2, the cells fixate the CO2 from the atmosphere and turn it into biomass or into products. We measure all the data, how the cell feels, how the temperature is inside the bioreactor, and we really get a lot of data that we can use to then make predictions and control the bioreactor in a perfect fashion. We pull samples from the bioreactor and bring it next to our sensor with the quantum technology and can ask the cell how it feels. We control the CO2, we control the oxygen. And then all the data is given to the biologist, so we can track the data, we can learn from the data. We also have an augmented reality that we used last year at the Hannover Fair. We pump the algae into this leaf-like structure, and there they get a special load of sunshine and CO2. And when they go back, they take the air with them, and we bring this air again through the bioreactor so that we have the perfect CO2 exchange. And we have the little multi-sensor on top that measures the light intensity and the direction, for example. This is our second bioreactor. We used it for our experiments, and here you can see how we made tiny little bubbles so that the CO2 perfectly goes from air into the bioreactor. So I'm convinced that this is the real basis for a circular economy, because this is the way to really take CO2 from the atmosphere, bring it into the bioreactor and turn that into products. We can take CO2 from the atmosphere and turn it into food. We can eat the algae. We can turn it into medicine or into cosmetics. We even can turn it into bioplastics. So instead of using crude oil, we can use the algae, turn it into bioplastics. We use the bottle for a while, and then we burn it, and we only set free the CO2 that we fixated before. So this is a real circle. And if we do that in an industrial fashion, we can generate enough to then generate different products, and we can replace fossil resources. Also the water, we run in a circle. So we always use it again. And this is also very sustainable, because we don't have to give nitrogen or so to the corn on the field. We keep it in the system and recycle everything. Obviously, with this 15-liter bioreactor, we cannot save the world. We have to have much higher volumes. We have to use artificial intelligence. We have to combine it with new technologies, for example, photovoltaic, to generate the electricity to run the system. We need to harvest the biomass in an efficient way, and we have to use new organisms, for example. And at the end, we have to process what's coming out of the bioreactor. We can do this in an old petrochemical fashion with 800 degrees, but we can also do that with enzymes at 37 degrees. So we can have bioprocesses that are more energy efficient, and we can turn the algae into new products. You might still think, well, this is not enough to save our planet. Maybe we need 2 or 3 planets to generate all the resources that humans need. Let's do some math. Well, all the plastic that humans need per year add up to about 0.9 billion tons of CO2 equivalents. And 1 ton of algae fixates about 1.8 tons of CO2, and we can grow about 6,000 tons of algae per square kilometer. If we add up all of this, we end up to a tube system of 84,000 kilometers. We need this to substitute all the plastics that humans need per year, and this sounds like a lot. But at the end, this could fit on 1% of the Sahara. On 1% of the Sahara, we could harvest enough sunlight and grow algae to not need any fossil resources to generate plastics. So it is possible. And we are just at the beginning. With the Max Planck for terrestrial microbiology, we did some experiments. We made new cells, synthetic biology, and these can actually fixate 2,000 kilograms of CO2 per square meter a year. So these are lab experiments. We are just at the beginning here, but it is possible. So when we use regrowing resources, we can transform them into products. We can use algae, but we can also use corn. Obviously, we want to eat that most of the time, but we can also use waste. We can use waste wood, or we can use waste from the food industry and turn it into products using bioprocesses. Steve Jobs said, "I think the biggest innovations of the 21st century will be at the intersection of biology and technology. A new era is beginning." Just recently, with the new inventions in biology, we have the tools to generate almost everything that humans need with biotechnology. We can produce food, we can produce medicine and drugs, we can produce plastics. All of this is technically possible with bioprocesses. And we can use regrowing resources to run these processes. So we can create a circular economy by fusing technology with biology. I'm a biologist, and I think this is really the foundation of a circular economy. We can generate a sustainable future. We can generate enough food for everyone. We can use regrowing resources. We can live in a climate-neutral fashion, and we can generate a circular economy. Well, I'm a biologist, but some other scientists may say, well, it is hydrogen, maybe it is smart algorithms. I think the problems of today are so big that we probably will not have one solution, but this is a big key, and others will be presented at the Hannover Fair as well. So there are inventions and innovations out there that can solve our problems. I'm convinced humans created the problems, and we can solve these problems. But we cannot do this alone. We need politicians to understand and listen. We need politicians to invest in these ideas. We need, for example, the EU, UN and the governments to set the right goals. We need smart engineers to work on these ideas. But the problems will not be solved within the next 5 years. This is something, the transformation of industry away from fossil resources will not be done within 5 years. It will take maybe 50 years. And therefore we also need the next generation to work on that. And we heard that before. The next generation read a lot about climate change, about the pandemic and about the war. But we have to give them an inspiration why it is worth working on a great future, because there can be a great future. This is your job as journalists. Make the kids believe in a good idea, make them work on that. You can inspire them, you can stream these ideas, you can talk about these ideas, you can write about these ideas. Please help the young generation to really look positively into the future. At the Bionic Learning Network, this is always our goal. We want to make kids smile, we want to inspire girls and boys, engineers, scientists, journalists, everyone. We also want to inspire old people and young people. We are convinced that technology is the key to a good future, and we can do this together. And with this, I wish you a great day today. You can ask me more questions later. I wish you a great Hannover Fair. Keep your eyes open for the solutions that are out there. Spread the news, inspire people, and thank you for your attention.